Cognixia actually, so I'm a part of the Cognixia team. So I'm a trainer. So it's a world's leading digital talent transformation company. So there are 150,000 plus professional trained worldwide and 7,000 plus industry veterans as instructors. Talent development in 55 plus countries, $8 million fully owned subsidiary of Collabora Group. We are the authorized partner, training partner for Red Hat, ITIL, Microsoft partner, Automation Anywhere, AWS, and many more. The awards, the Asian Training and Leadership Award in Dubai, ISO 9001:2015 Certified Quality Management System, and the other you can see on the screen. So our offering is Rewire, B2B, Rewire Direct, Jump, Managed Training Services, Performance Consulting, Learning Paths. So we have 24/7 access to the recorded video for which is available on the LMS, and there is kind of this is lifetime. This access is lifetime. So the class which basically conducted by the Cognixia, so that all the classes get recorded and the access to the student or participant for the lifetime. So the question is why you need to choose Cognixia. So if you see some of the features which we offer in our content management system and in our training, so these are basically client tailored content. Means we are very much our contents are very much related to the real time scenarios, and it is very helpful for you to get a good job or to get a good career path in your personal and the professional development. Data driven learning strategies, industry veterans as instructors, dedicated program managers. We have multiple training modalities, virtual plus on-site, state of the art cloud labs. This is also one of the good features. Participant performance reviews and the evaluation, insight monitoring and reporting. Center of Excellence. So we offer different types of courses, which you can say is a present and future of the IT industry. One of them is machine learning, microservices, RPA, Internet of Things, big data analytics, DevOps, cloud computing, cybersecurity, professional development, and BI technologies. Now let us talk about the Kubernetes services. So before starting the Kubernetes services, let me just give you some introduction for the Docker, and then we will move to Kubernetes and then Kubernetes services. When we talk about the containerization, so containerization is basically a technology where you deploy your microservices applications in a very quick way. Containers is the most demanding technology in these days. If we compare with the virtual machines, in the virtual machines, when you are having the application which is running on the guest operating system, there are a lot of complexity which is resolved by the Docker containers. Docker is the containerization technologies, and Kubernetes is the orchestration tool. So what is orchestration tool? Orchestration tool is the tool which basically manages the containers. Let me try to show you with some example. For example, I have a container. So say an example, this is my container. Container is nothing but where your application is running. Okay, so there is a very deep concept for the Docker containers. So I'm not going in deep detail of that. So considering that you already know or you already have some idea before this demo about the containers, But if you don't have the idea about what is container and how to deploy the application in the containers, probably you will get to know in our Docker and Kubernetes lectures. Okay, so means in a quick way, if I want to explain what is container, so we have one container inside it, and this container is basically having the application which is running inside it. Okay, maybe your web application running as a container. So containers are very lightweight because they are using the Docker image, and the Docker image is very lightweight. Most of the time when the applications are running on the containers, then you cannot rely on the containers, on these running containers. The reason is that rely in the sense, I'm not saying that if you deploy your application will not be accessible by the customer, or it's a kind of a orphan application. It's not like that. It is something like that your application is running on your container, which is basically running your business. And if you want that application to be always up and running, if you want your application which is running on a container, it is always up and running, you need to orchestrate it. So if you want to run the application and you want always up, what you need? You need the orchestration. So what is orchestration? Means management. Okay, so if you see word orchestration anywhere, it means management. So what is the management in the terms of containers? So management of containers means your containers are taken care by someone, and that someone is your container orchestrator. For Docker, there is a container orchestrator which is Docker Swarm. Okay, that is also one of the orchestration tool. And there is Kubernetes. So Kubernetes, we write it K8S also. K is the first letter, S is the last letter of Kubernetes word, and 8 are the total number of letters in between. Okay, so Kubernetes is basically one of the very demanding and very powerful orchestration tool for the containers. So now my application which is running as a container, if we talk about the Kubernetes, then it is running as a pod. Okay, so let us understand the concept of pod. So in a pod, so for example, this is a pod, and pod is basically a wrapper around the container. So for example, there is one container running inside my pod. So pod is what? Pod is a basic unit of the Kubernetes. So when we talk about this pod, so it is having container inside it. So say an example, this is the container C1, and which is running on some port number. A pod can have a single container or multiple containers. I'm not going to discuss about the multi-container in this demo. I will show you how you can access this particular container which is inside a pod. And what is in the container? There it is basically having some application which is running on that container. So similar way, there are multiple containers. So if I have a container like this, there could be multiple containers. So I have this container also, or you can say this pod. So every pod is having one IP address, okay, which is dynamic. And these pods, these are running on a network. So for example, you have some machines. You have some machines, say an example. So for example, we are having our host machines. Kubernetes, whenever we say Kubernetes, it is a cluster. So cluster means you have the set of machines. Out of these machines, there are some master machines and there are some worker nodes. Master machines are those machines where master component of Kubernetes is running. And worker nodes are the machines where the ports get created and means custom ports I'm talking about. Ports you can create on the master machine also. But the applications which we are running, we are mostly running it on the worker node. Okay, so for example, this is my one machine, this is my second machine, this is my third machine. So consider that I have three nodes. So first node is my master node. Let me designate as K master node. And my second node is the worker node, 1. And third node is worker node 2. So these are virtual machines or maybe the physical machines, but most of the time we take it as a virtual machine. First of all, before installing Kubernetes on this environment, what we need to do? We need to set up a network between these. So these three machines should be in the network first. If they are not in network, you cannot create a Kubernetes cluster. On top of this, we basically create one more network and which is called the pod network. Okay, we create one more network which is called the pod network. So what is pod network? Pod network is the network on which the ports are running, and there are different plugins are available. The one which is very commonly used is the Calico. So Calico plugin is used for the for creating this pod network. Once the pod network is created, then we can create the ports on this network. So for example, if I want to create this port, so this port will be created on this network. This port will be created on this network. And every pod network has one CIDR range, which is the IP address range. Okay, every pod network is having one IP address range. For example, we call it CIDR range in networking terms. For example, if it is 192.168.0.0/16, let us consider this is the CIDR range. You can define whatever CIDR range you want to define. It means all the ports get created under this IP range. So for example, if I take this one, uh, uh, I'm just considering that it will have the IP something like that, 168 dot say 1.1. Okay, so there are some fixed or reserve IP addresses. I'm not considering that. So 192.168.0 or maybe 1.2, not 1.2, maybe, yeah, you can say 2.2. Okay, so let me just show you quickly that how this get created. So if you see my screen, so I have already one cluster, and if I say kubectl get nodes, so here you can see I have three nodes. One is master node, one is worker node 1, one is worker node 2, and my systems are on the I have created this infrastructure in AWS. I have taken three machines, and all these machines are basically Ubuntu machines. And I have used Calico plugin to create the network. And now these three machines are on the network. If you want to see how many ports are running, you can run a command kubectl get ports. Okay, so yeah, let me just increase little bit font. Okay. So if you see kubectl get ports, there is no port. Let me create a port. So to create a port, kubectl and run, let me give the name pod as pod 1. And I want to use the image, which is say Nginx. Okay, so a port get created. Now, if I run a command kubectl get ports, so you can see there is one port which is in the creating state at this moment, and it will be created soon. Now you can see it is in the running state. Okay, now I want to see where this pod get created. So this pod get created, you can run this command kubectl get pods -o wide. So this pod get created on worker node 1. So what is worker node 1? This is one of the virtual machine. So you can see this is my virtual machine, and this virtual machine is having this worker node 1. And I have another virtual machine. Let me just change the host name as worker node 2. And this is my worker node 2 machine. So my pod which get created on this particular virtual machine, right? Now the question is that how to access this application which is running on this machine. To access this application through the host machine, see, pod network is a secure network. You cannot access the application directly from the pod. You can access on the host machine by using some port forwarding, but that is not a best practice. So the best way, if I say there is a curl command, so curl command basically returns the HTTP response. If I say curl, and this is the IP address of my pod, if I say curl, so you can see I'm able to see the HTTP response of my application which is running as a pod. But this is only accessible within this cluster or on this host machine, but how my client will access it. So if I say kubectl or if I say curl localhost port 80, because nginx runs on port 80, so you can see it is saying connection is refused. The reason is that on port 80 there is no application is running. The port 80 is not in use. So how this application was accessible here? Because I used the pod IP address. Okay. So now the situation, if you see over here, I have this port where my application Nginx is running, and I want to access this application. So this application can be accessible to this cluster, but with the pod IP address. And pods can be created and terminated at any moment. If you give the pod IP address as where the application is running to your client, or if you configure somewhere, then it is not a good idea, because the pod IP addresses are keep changing whenever they are terminated. So the best practice is that you create a service. Now my client who wants to access application, say an example, this application, okay? So if he wants to access this application, then for example, this is my client. Little bit long face. And this is my client. And this client wants to access this pod. So there is a service here. Okay, so let us change with some color, like this is fine. Okay, so this is my service. Now this service, so I will say this is my service, or you can say service layer. Okay, now this service will be accessible to the client. So this service will have one static IP address. Static means fixed IP address. Okay, and there are different port mapping happens with the container. Okay, so let me just show means what I mean. So now what we are going to achieve basically, so this client who wants to access this application which is running on this pod, so client will basically connect through this service. Okay, so mechanism could be different, but ultimately we need to target the service. So client is going to access this service, and this service has a label selector. Okay, so there is a concept of label selector. So what is label selector? Every pod have every port has some label. And service select the ports on the basis of labels. Okay. So for example, let me show you how to create the labels. So for that, we need to write the script. So let me create a script pod.yaml. So if I say API version, don't worry about this script. When you get enrolled, you will get familiar with these terms which I am writing here. So API version v1 kind pod and metadata. So I'm creating a pod and I will give a name as say pod2 and label. So here I'm defining the labels. Okay, and you can define any label. I'm saying app equals to nginx app. Okay, so this is the label. Now in Kubernetes, when we are talking about the orchestration, it means replication comes into the picture, deployment comes into the picture, so many things which comes into the picture. I'm showing you an example of a single port, but in reality, when you have the application in the production, so it is not a single port. It can be multiple ports, and these ports are replicated ports. Okay, so that thing is basically there will be some replicated ports. So one service is basically having multiple ports which are under the one service. Okay, so consider in that way. So I'm creating a label. Now next I will create the specification. So actually I'm not using any tool, that's why it is just moving here and there. So if I say containers and the name of the container, I will say C1 and kind, which is not kind, it's image. So let us consider I'm using nginx image. Okay, so now I need to create this port. So if you see kubectl get ports, okay, so let me remove this port, the one which is running. Kubectl delete pod1. Pod1 is getting deleted. Okay, now let me create a port which I have just created. So you can run a command kubectl create -f and pod.yaml. So pod2 get created. If I say kubectl get pods, so you can see pod2 get created and it is up and running, right? So this application I want to access externally, right? Because if I say kubectl get ports -o wide, so I can access this application on the basis of the IP address, but I cannot access it. I cannot access it with on my cluster level. To access this cluster level, what we need to do? We need to create a service. Now there are different types of services are available. So let me just go back here. So what is service? Service is an abstract way to expose the application running on the set of ports as a network service. Okay, so this is an abstract way because you are using the DNS to configure this service IP address. Okay, so it's not a direct way you are accessing it, but it is a abstract way. With Kubernetes, you don't need to modify your application to use the unfamiliar service discovery mechanism. Kubernetes gives ports their own IP addresses and single DNS name for a set of ports that can load balance across them. One of the feature of the Kubernetes service is that it is having a load balancing. For example, if you are running multiple pods which represents the same application and they are having the same label, then you need not to worry about the load balancing. How, if there is lot of traffic comes, then how it will be load balanced to the multiple pods. You need not to worry about that because it will be taken care by the service. Service has its own internal load balancer feature. So if there are a lot of traffic comes, it equally distribute to the ports, which is under the service. Okay, so that is also one of the feature. Now there are three types of services. First service is ClusterIP service, NodePort service, and Load Balancer service. Now let us first understand the ClusterIP service. In ClusterIP service, basically what we do, we want to access the application internally. Okay, if you want to access the application internally within the pod network, then we use cluster IP address. Okay, so cluster IP service, sorry. So cluster IP is the default Kubernetes service. The service is created inside the cluster and can only be accessed by other ports in that cluster. So basically, we use this type of service when we want to expose a service to other ports within the same cluster. So let's take an example. You are having, say, two or one web application and one database application. The database application you don't want to expose externally. You want to keep it internally. So in that case, for that service, I will make it as a cluster IP service. Whereas if we talk about the web application, so this is basically accessed by my client or the end users. So I will keep this web application on the external, means I will expose this application externally. So if you want to expose the application externally, then you can use the NodePort service. So NodePort service is basically a service by which the application which is accessed by the service, it can be accessed externally. But how it can be accessed externally? So there are different ports basically. So if we talk about here, so this service, right? So this service is basically mapped some ports. So let us talk about those ports. So first port is the target port. So I'm talking about the node port service. So target port is the port which is the containers port. So when your application is running with the Nginx and Nginx is running on port 80, so target port will be the port 80. Means this service is going to map to port 80 of the pod or container. Next is the simple port. Okay, so next is the port. So port indicates that the service port. So service port means you have to map some port number of this service to the container. So container port is port 80, I'm mapping, but which port, what will be the source port? So source port is the service port, which can be any. You can keep it 80, 90, whatever. Okay, but mostly we keep the same port number as the target port. In case if it is in use, then you can change with the different port number. Next we have the node port. So node port basically it has a range 30,000 to 32,767. These port numbers mostly we open it on the worker nodes. When we talk about the worker nodes, the application is running on the worker node all the time. It's not a compulsion that it will be running only on the worker nodes. It can run on the master node also. But we put some constraint and some tainting on the master node so that the pods should not be created on the master node. So most of the time the applications are running on the worker nodes, and we want to access the applications on port number 32 30,000 to 32,767. So these ports should be open on your worker nodes so that you can access these applications externally. And we will see in a bit practically this, how to access this application externally. So that is the NodePort service. If you want to access the application internally within the cluster, what is the use case? Use case is that if there is a pod 1, which is a web application, and pod 2, which is a database application, they want to communicate, they can communicate on the ClusterIP service. And they are accessible, means both are accessible internally. But now you are thinking that the application should be accessible externally and the database should be in the internal network. Then for the database you will create the cluster IP service. For web application you can create NodePort service. Now there is third type of services also available, which is the load balancer service. Load balancer service, it does not mean that it is overwriting some internal behavior of the services. As I mentioned earlier, that NodePort service is for the external, and every service has one internal load balancer by which they are basically, means there is a load balance happens between the pods. Now, if you are running your application on a cloud, or if you are using some internal load balancer, then you can use that instead of the service load balancer. So this is a standard way to expose the service on the internet. All the traffic on the port is forwarded to the service. It's designed to assign an internal IP to act as the load balancer for the service. There is no filtering, no routing. Load balancer uses the cloud service. Okay, so if we talk about the external on internet, if you are accessing the service, mostly we use the cloud computing. So Kubernetes is a service in the Azure, AWS, Google Cloud. So all the platform, almost all the platform, they are having a dedicated Kubernetes service. So if you are using that load balancer, say an example on the Google Cloud, and you are using Google Kubernetes engine, then if you have a load balancer service, what it will do, it will basically create a or gives you one IP address. And through that IP address, you can access the application. So that load balancer service basically, it's basically one more load balancer which is provided by your cloud service. And because if you are accessing the application externally, and when you access the application externally and you are using a load balancer service, then it will provide you one public IP address, and public IP addresses are not free of cost. So that's why we call it as a, means it's an expensive service. So there are other ways which we call the ingress services, which is not a part of today's discussion, but with the help of that you can have a single IP and which is exposed to the service, and all the services. For example, you are creating hundreds of services, and if you use the external and you want to access it externally, then you need the 100 in public IP addresses. So that will be very costly. Instead of that, we use a concept which is called the ingress services. And with the help of that ingress service, what we can do, we can have single IP address, and we can configure all the services as a cluster IP services, and we can access those services with the ingress IP address. Okay, so that is a basically, we are not going to discuss in detail, but some introduction I wanted to share with you. Okay, now next is how to implement this. So let us see how to implement this. So I already have a code, and you guys can, if you want, you can use this code. So we'll take one example. So here I have created one deployment, because deployment is little bit advanced topic in the Kubernetes. So that's why I'm not creating this deployment. Instead of that, I have created this YAML file. So let me just open this YAML file. And let me share with you on the chat window. So instead of this deployment, which is basically creating a pod, I have created this pod.yaml file. Okay. Now this is the example of NodePort service, but the same service we will see how to create the ClusterIP service. So let me just copy this service, and if I go to my, so this pod is running, you can see pod 2 is running. And now let me create a service. Let me explain you what this, I'll call it nodeport.yaml file. So YAML is the language which we are using to create the script or manifest file. Here, what I'm saying, this is a script file, okay? And you will learn this script file how to create this when you get enrolled, right? So here, API version is v1, kind service, okay? So I'm going to create a service. Name of service is my service, and I'm using the same label which I have created for my pod. The reason is because my pod is having a label, so it should be a part of that service. Then I can access it. So how they can access? On the basis of the label selector. So I'm defining a label here, okay, and the label is app nginx app, which is the same label which I will show you again, okay. And then the specification, I'm saying specification of my service is that it is going to select those ports which has app equals to nginx app, and type is equal to node port. So here I'm defining a node port service. As I mentioned, there are three ports when we discuss about the node port service. So first is the node port. So node port is the that number. If you don't mention it, it will automatically pick up the port number from 30,000 to 32,767, any port which is not in use. But if you want to fix that that port number, you can fix it. Port 80. Port 80 is the node port service port 80, which is mapped to target port, port number 80 of the container. Let me save this. App equals to nginx app, that is the label. Let me just show you that pod.yaml file also. Here you can see app equals to nginx app. So we are using the same. So now I want to create this service. So we need to run a command kubectl get service. So if you run this command, it will show all the services which get created under this on this cluster. So far there is one service, but that is not created by us. This is the Kubernetes inbuilt service, and which is type ClusterIP. So we are not going to discuss. So let me just talk about kubectl and create -f, and my service name is NodePort Service.yaml file. So my service get created. Let me see whether that service get created or not. kubectl get service. So here you can see there is a service, my service get created, which is NodePort, and this is the IP address of that service. Okay, and here you can see port 80, and port 80 is basically which get configured to access that application. If you want to access internally, if you want to access externally, then you have to use this port number. Now let me just say kubectl and describe service and my service. Okay, so here you can see there is a endpoint. Endpoint means what are the different ports which are under this service. So that basically indicates the endpoint. So if I see kubectl get ports minus o wide, then you can see here that this is the IP address of my port. So it means this particular port is basically mapped for my service, right? This is mapped for my service. So 192.168, so this is the same port number, right? So this get mapped. So it means the so this particular pod is now getting registered under this my service. Now it means if I know the my service, so if I say kubectl get service, now this service is a NodePort service. Now if I want to access this IP address, if I say curl and this, so you can see I'm able to access that Nginx service. Now I want to access this Nginx service on the web browser. So let us see how to access this service on the web browser. So we know, let me just grab the IP address. So this is the public IP address of my master. You can take master, worker node, any one of this, okay? And if I say colon and that port number, which is 31,111. So you can see now I am able to access this application externally. So how this application is accessed externally? Because of the Kubernetes NodePort service. Okay, so with the help of the NodePort service, I am able to access this application externally. Right. Okay, so now, so this is the example of the NodePort service. If you want to access the application only internally, you don't want to access externally, you can change this definition. Okay, so if I say how to change this service, you can change a service with the kubectl edit service and the service name, which is my service. So I want to change this service. Okay, and here you can see the down. If you come over here, you can see type is NodePort service. So let me change it to ClusterIP service. So cluster IP. Okay, because it's a cluster IP service, so there will not be any node port. Node port is only for the NodePort service. So I'm saying port, which is port 80. If I say kubectl get service now, so now you can see this service is changed to cluster IP service down one. Okay, if it is a cluster IP service, see the port numbers. Only single port is basically mapped, not the external port. So it means the service which I was accessing here, now I cannot access it because that port number is removed. Now this service is only accessible internally. How to access it internally? So if I go here and if I say curl and this, so you can see I'm able to access it internally, but I cannot access it externally. Now what is the use if it is in internally? As I had given you example earlier, that for example you are having a web application and database application. So database application, database basically application means you have that software, right? Where your database, MySQL or Oracle, some database is running. And you don't want to expose that database externally. If we take the example of Google, if we take the example of Facebook, you know the facebook.com. You go and like the things, you can delete the thing, you write your post, but you don't know where the data is getting stored. What is the database design for that Facebook application? So this thing is maintained within the cluster of, or you can say in the private environment. But yes, what you are accessing, that is a public environment. So if you want to access the application externally, then you need to use the NodePort or the load balancer service. And if you want to access the application within the network only, then you use the cluster IP. So there is a question, what is the use of cluster IP address? There are nodes containers within the cluster host the application. So node IP is important, right? Okay, so basically cluster IP address, as I mentioned in this diagram. So you want to access this network, okay? You want to access this network, but through the host machine, how you can access this network? Through the service. If your service has some IP address, and this IP address will be fixed, static IP address, even though your container, if your ports are getting created, removed, updated, there will be no impact on the service IP address. So this service IP address is basically used to access. So for example, this particular pod get removed and new pod get created with the same label. Then this service IP address will be same, whereas this IP, the IP address of the port could be changed. Okay, and the master, how master will know that means which application I need to access? That is through the service IP address. All right. Okay. So now sometimes, so now if you see my service, if I say kubectl and describe service or SVC basically, and my service name is my service. Right? See, the endpoint is same. The only change which had happened when I modified that script, that is because of this cluster IP service. Okay. So if you want to create or if you want to remove the service, you can remove the service as well. Okay. If you want to remove, you can remove the service. For example, if I say kubectl delete service and the name of the service, which is my service. Okay. So the service is deleted. All right. Now let us talk about the third service, which is a load balancer service. So if you want to access the application internally, externally, so there are two ways. One way is the NodePort service, and second is the load balancer service if you are using the load balancer of the cloud system, means like AWS, Google Cloud, etc. Okay, so let us go back here on my notes. Okay, so in the load balancer service, just let me just copy this code. So let me call it loadbalancer.yaml file. Okay, so API version v1, kind service, name of the service, which comes under the metadata, and this is the Nginx app. Now you can see the specification selector is Nginx app. So I'm saying app equals to Nginx app. This is my label selector. Type, and type is load balancer. Now the ports, because as I mentioned, load balancer has a feature of the node port. So node port 31,000, I'm exposing this port number, and port 80. Port 80 means it's a service port, and target port 80, it means it's a port of that particular container which is running inside the pod. Okay, so let me just save this. Okay, actually I'm not running my application on a cloud environment, so my IP address will not be I will not be able to access the IP address. If you run your application in the cloud environment, then you will get that IP address. What I'll do here, I will open that. If I say kubectl get ports minus o wide, so this is the port. Let me change the image of the port. So how do you know what is the image of this port? You can run a command kubectl describe pod port2. Okay, so here you can see it is running with the Nginx image. I want to change this image. Okay, for my running container, you can do that. You can run a command kubectl edit pod, and my pod name was pod2. I want to change this image. So let's make it, there is one image which is my custom image. It's a Docker custom image. So let me use that. And I will use that image name is web app. Okay, so the pod is edited. So if I say kubectl and get pods, so my pod is running, but now it is running with the different image, and that image is my custom image which I have developed in the PHP. Okay, now let me create my load balancer service. So kubectl and create -f load balancer dot YAML. Okay, so service get created, which is my service. Kubectl get service. So new service get created, and you can see here the external IP address which is in the pending state, and it will be always in the pending state because it is of type load balancer, and I am not using any cloud system where I can access this IP address, right? So what I'll do, kubectl and get pods. If I say describe service, and services my service. Okay, so here you can see the endpoint is same. Okay, the port is not set. Okay, there is no port set for this, but this port number is the node port. Okay, so this is my node port. So let us try to access this application on port number 31,000 now. So see, this is my application, and I'm able to access this application. Okay, now let me change the image. So means you need not to do any change in the service, and consider if I edit my image. So if I say kubectl and edit port 2, now let me change the image to, so if I say change the image to Nginx again. Okay, so let us wait. Looks like it is cached. Let me close this. Let me copy this side, close it, and open again. Okay, so if I say kubectl, let me open in some other browser. Okay, let me open in the Edge because I did not close that, right? So let me open over here. So now you can see I'm not getting my custom image. I'm getting my Nginx image, right? So this Nginx image is because I modified my port 2 definition with respect to the image name. So that is why this particular image is replaced. I did not change anything in my service. Okay. Now let us take one more example and then we will wind up this session. So in this example, what I will show you that if there is a web application and there is a database application, how they are going to interact with each other. Okay. So what I'll do here, let me close this and let me edit this definition again. Okay. So I will call it as a same image, the one which I was using because that's a custom image. Okay. And I will create one more. I will create one more pod. So if I say vi pod.yaml, let me create another pod, say pod 3, or I can, okay, I can't. Okay. So if I say pod 3, and if I say app equals to db app something, okay, and the container c1 is fine, and the image I want to use my backend image, which is MySQL. Okay, so I have one. Okay, so now let me create this port, kubectl, and create -f and pod.yaml. Pod 3 get created. Now I have kubectl get pods. So there are two pods. Second pod is getting created. Let it create. So because that image is little bit heavy image, that's why it is taking a little bit time. Now you can see it is basically in the running state. So my web application, now let me just go back here and refresh this. Now I am accessing this. If I try to, enter something. So if I say enter name, say Raman, something, you can put any values. Okay, and add employee. So it will throw the error because in this application, basically what I have written that you need to connect to a database, and that database will have some service name as a DB service, and I want to access this application to insert the data into that database. So that objects has not created, and I did not create any service as well. So let me create a service for the database. So I say that I'll take a copy of this NodePort service, say db.yaml, and if I say vi db.yaml, what I will do, I will create a service, and the name of the service I will say db service. Okay, which will select my pods, which is having db app as the label, and here also it will be db app. Okay, and the type of service will be node, not the node port, it will be the cluster IP. Because it's a cluster IP, so you can define the port, and the port number is 33064 for MySQL, and target port is, I'm giving the same. Okay, so 3306 port is the port number for MySQL if you want to access it. Okay, so let me just save this. And if I say kubectl and create -f db.yaml, now the DB service get created. How do you know? Kubectl get ports, get service. So there is a DB service which is cluster IP service, right? Now, if okay, so now I have one service which is my service. So let me just go inside the pod 3 kubectl execute -it the pod 3 -bash. So I'm going inside the pod 3. So pod 3 is basically, it is having MySQL image. So MySQL, and I have a username as root, password is this one. So I'm connected to my MySQL. So what I'm expecting that, so there are some commands which I'm running, which is the SQL commands only. Okay, and don't worry if you don't know SQL, that is fine, absolutely fine. This is for the example point of view. So if I say create, so I need to create a database which is company database. Okay, so if I say now show database, so there is a company database, right? Now if I say use company, okay, so the company, I'm inside the company database. Now here basically in my application, what is happening? It will insert the record into a table which is the employee table. As of now, I don't have any employee table here. So I need to create that employee table. So let us create that employee table. So if I say create table employee, and I'm having two fields. One is the name field and second is the mobile field. Okay, so this table get created. So if I say select, so this is the command which basically shows all the records of employee table. So there is no record. Now what I will do, I will access my application one more time. Okay, I will enter a name, say Raman, and some mobile number, add employee. Now you can see it is saying record created successfully. Let us verify this. If I go over here and if I say select asterisk from employee, so here you can see that there is one record added. How it is added? Because I have two ports, one port which is running the web application, another port which is having a database application. So my web application is going to insert the data into the database, and whatever the structure is required, I have created that structure, and my ports is they are able to communicate to each other. So now if means it's a real time scenario. All the applications are database oriented application, means where you are pushing the data into the database tables, and these database tables are basically running on the private hub. okay, on the private, not on the public side, right? On the public side, my web applications are running. So this is how the database is basically getting updated from the web application. Okay, so there is a question, do we have a reference document for this session? Okay, so probably yes, you will get that. So now you can see that I am able to retrieve the data. Let's say add one more record and just verify one more time. Job one, I will add some value. Okay, and if I see over here now, okay, so you can see another record got added. So this way, the applications which are running externally, they can access the application which is running on the internal network. And this is the way how the ports can communicate to each other by using service. Thank you very much. I'm signing off now. Bye. Stay healthy.